Hello everyone, welcome back to Algebra 1 with Miss Betsy. Once again, I'm glad that you are here joining us with this class. We're going to be studying about opposites and absolute value today. And I am using as my text the second edition of Algebra 1 for Christian schools. It's published by Bob Jones University Press. I'm beginning my discussion today on page 6 of that text. You don't have to have the same book I do if you just simply want to learn about opposites and absolute value. Just follow along with me. However, if you're trying to track with me using the exact text, it has to be edition 2. The third edition is not compatible with the way my lectures are running. So let's go ahead and get started with prayer. Father God, we welcome your presence with us today. Lord, I thank you that you are so very awesome, that everything that we study comes from you and that you created it and that you designed it. Father, I ask that you would help us to learn today the things that you would have us to learn. Father, give me the ability to communicate well and give to my students and to anyone who's watching this video the ability to understand and comprehend the material that you'd have them to learn today. And I pray in Jesus' name, amen. Okay, our lame joke for today. Why did the chicken cross the road? Well, everybody thinks, oh, the chicken crossed the road to get to the other side. Well, no, here in the great state, great country of Texas, the chicken crossed the road to show the armadillo that, yes, it really could be done. So let's go ahead and talk about opposites and absolute value. And we're going to be using the number line to illustrate the concept of opposite. And for those of you who are with me live here in our homeschool co-op, I know it's going to be so delighted that today's video lecture is much shorter than the first one was. We know that you can show a picture of any number on the number line. Specifically, we're going to be talking about integers today. What are integers? Integers are positive and negative counting numbers, if you will, and zero. Counting number would be, how did we start to count when we were little teeny tiny? Did mom say, okay, we're going to count 0, 1/2, 1, 1.5, or did we start -7, -6, -5? No, we learned to count 1, 2, 3. Okay, those are whole numbers. And those are natural numbers, 1, 2, 3, what you naturally count with. You add 0 to that, you have whole numbers. You add the negative numbers, negative integers, and we have what we call the class of integers. So integers don't include fractional parts. And we're going to graph integers today on the number line. And we know that the way that we graph, we have this instruction here, and we said graph 4 on the number line. We're going to take a solid dot. We're going to go over here 4 on this horizontal number line. And we're going to draw a solid circle there. And this, okay, that was a little creepy. There's this solid circle here, and that's called the coordinate of the number 4. My power blipped off for a minute, but I'm grateful that it came right back on so that I can keep on recording. If we look at 0, how far is the graph of 4 on the number line from 0? Remember, each from 0 to 1 is 1 unit. So we have 1 unit, 2, 3, 4. So 4 is 4 units to the right of 0 on the number line. 4 units to the right. Here we have 0, 1 unit to 1, 2, 3, 4 units to the right. Well, let's go ahead and see what we would graph if we're going to start at 0 and we're going to move 4 units to the left. We are going to go, 1 unit takes us to -1, -2, that's 2 units, 3 units, and 4 units, and we're going to graph that number. So what number do we have that is 4 units to the left of 0 on the number line? Yep, we have to the left. We have a negative 4. 4 units to the right on the number line, we have a positive 4. And what we're talking about here, trying to find where my cap is, yes, it's right here. Opposites are numbers that are located the same distance from 0 on the number line, going in opposite directions. Positive 4 is located 4 units from 0 towards the right. Negative 4 is located 4 units from 0 to the left. So let's go ahead and think, okay, well, if we have 75 that we're going to graph on the number line. Actually, I don't think I even want to do 75. Let me draw this back. Negative 75. This solid circle here at the coordinate indicates the graph of negative 75 on the number line. How many units is negative 75 from 0 on the left? It's 75 units to the left on the number line. Well, what number is going to be 75 units to the right? 25, 50, a positive 75 is 75 units to the right. So we see that opposites are numbers that are the same distance from 0. And this idea of distance is really, really important. It's not that you have a negative distance or a positive distance. Moms and dads, wouldn't it be really cool if when we got in our car and we drove 100 miles to Grandma's house, well in my house case it would be 1,300 miles, drive 1,300 miles to Grandma's house. That's positive 1,300. And then we turn around and we come back our distance the same way and we're going back in the opposite direction and the odometer unwinds itself, the gas goes back into the car. Well, no, distance is always positive. So, the distance there from 0 to a 75 is the same as, I should have gotten another color pen, the distance from 0 to 75 is the same as the distance from 0 to negative 75. They're just in opposite direction. So this is where we get the whole concept of opposites. And opposites also have another name, and that's called additive inverses. So we're going to say we have opposite. They're also called additive inverses. And it's very, very important, kids, moms, dads, adults, whoever's watching this, that every bit of vocabulary that's mentioned by me, mentioned in the text, you need to learn. It's the language of algebra. And it's not so much that it's hard, it's just language. You know, think about the doctor talking. He has his own terminology. The lawyer has his own terminology. We as believers have our own terminology when we talk about our relationship with the Lord. But if you don't understand what the vocabulary is, it's meaningless. If I tell you, what's the additive inverse of 7? I don't have a clue what you're talking about. Additive inverse is the opposite of 7. I just showed you on the number line that opposites on the number line are the same distance from 0. So, but in opposite directions. So if you start at 0 and you have a 7 units from 0 and towards the right, what's the opposite going to be? Well, it's 7 units from 0 in the opposite direction, so it's a negative 7. So 7 and negative 7 are opposites. 7 and negative 7 are additive inverses. What does it mean when you have additive inverses? That means if you take a number and add its opposite, you're always going to get 0. Take a negative 7 and you add its opposite, you're always going to get 0. So when you have additive inverses, when you add two opposites together, their sum is always going to be 0. And that's because what you're really doing is you're using your 0. See if I can do, probably not. Okay, since I'm balance challenged here, I'm going to use all of my fingers here. This yardstick rather, is balanced. Right here is 0. Additive inverses are those things that keep your seesaw balanced. So if you have a negative 23, what's a negative 23 going to do? It's going to put your seesaw like that. How do you have to get that seesaw balanced? Well, you go over here to a positive. You go over 23 units from 0 to a positive 23, and your seesaw goes like this for a moment, and then it levels out. So opposites, or additive inverses, are numbers that are on opposite sides of the number line. It's the positive number, negative 73. Its opposite, you put a negative sign in front of it, negative 73. If I ask you to give me the additive inverse of a negative 6, over here on the negative side of the number line, well, its opposite, or its additive inverse, is a positive 6. Additive inverses differ only in that one of them is positive, one of them is negative. The numbers are identical. And we were talking about distance. Distance is always positive. You're going to find that that's what absolute value is. Absolute value is a very important concept, very important vocabulary, absolute value. What absolute value is, that's distance. And it's the technical definition here is the distance from 0 on the number line. Distance from 0 on the number line. So our quick little illustration is this one that we've just talking about. Okay, I've got my little number line here, and I've got a 0, and I've got a 7, positive 7, I'll say. I was going to write 17. What's the distance from 0 to 7 on the number line? Remember, 1 unit is the distance from 0 to 1 on the number line. So from 0 to 7, the distance from 0 to 7 is 7. That's the absolute value. Now there's a special way that they use to define absolute value. It's these little bars. It's like 2 L's. And in the middle, what this is saying is, what is the absolute value of 7? What is absolute value? Absolute value is the distance from 0 on the number line. How far is it from 0 to 7 on the number line? Or what is the absolute value of 7? It's 7. Now, how far is it to go from 0 to a negative 7? Or, what is the absolute value of a negative 7? How many units from 0 on the number line is a negative 7? Well, it's 7 units. So the absolute value of 7, of negative 7 is a 7. The absolute value of a positive 7 is 7. And what you're seeing is distance. That's all we're talking about. Let's say that I start here and I drive east for 7 miles. And then I come back home and I start here, or actually, let's say my husband drives west for 7 miles. Now this is me, this is Mr. Jerry. And here's our fancy little car. Do you see why, if I would ever submit to teach a class at co-op on art, they would say, Miss Betsy, I think you're so out of your gifting. I'm going to start here at home. I'm going to drive in my fancy little car here 7 miles to the east. Mr. Jerry's going to start at the same time, but he's going to drive 7 miles in to the west. Now you think, okay, if we make this into a number line, -7, +7, what you said last time, Miss Betsy, is that the further to the right that a number is on the number line, the larger that number is. So your number is further to the right than Mr. Jerry's is. So you must have driven further. Everybody probably that's watching this knows that's not true. I drove 7 miles one way. My husband drove 7 miles the other way. We both drove the same distance. We both drove 7 miles. So this is an illustration of all that absolute value is. It's not positive, it's not negative. I didn't mean it's not positive. Distance is never negative. So whether you're taking, let's see if I'm still on the screen, whether you're finding the absolute value of a -18 or the absolute value of a +18, it's always that positive number. Now we can talk all about different fancy way of defining what absolute value is, but it's really just the positive number. Doesn't matter if we're asking for the absolute value of a negative, absolute value of a positive, it's always that positive number. And this is important to remember when we're talking about finding sums or differences of absolute values. Now let me show you something. I'm going to go ahead and erase this board. And then I want to pull this particular problem, a couple of particular problems, from our text on page 8. We're going to find that you have to be careful to tell the difference of, to discern between, okay, are they finding the absolute value of a difference or the difference of absolute values? Let me show you this. This says the absolute value, and it's not the same example they're doing, absolute value of 72 minus 20. Remember we talked, well, you've learned about order of operations, and it was, pretty please, my dear Aunt Sally. Some of you learned PEMDAS, a way of what do you do when you have a whole string of operations that you have to do: addition, subtraction, multiplication, division, parentheses, and you learned that your parentheses powers, multiplication, division, addition, subtraction, parentheses, exponents, multiplication, division, addition, and subtraction. At first, you had to work on parentheses, do everything in parentheses first, from left to right. Then you had to do multiplication and division in order from left to right. Then you had to do addition and subtraction in order from left to right. And we'll review this again. This is not a part of this lesson. Well, absolute value bars work like parentheses. If you don't already know this, make sure that you highlight this and that you understand that. And I'll show you exactly what I mean. Absolute value bars function like parentheses. What that means is when you have a problem that involves absolute value bars, you have to do everything that's inside those absolute value bars first. Absolute value of 72 minus 20 becomes the absolute value, 72 minus 20 is not a negative 52. The absolute value of 72, do I really want to do this? 72 minus 20, let me think. I may have created one that wasn't really good. Okay. Every once in a while, as I do these videos and I come up with something that I'm creating off the top of my head, it doesn't work the way I want it to. there is, let me just go ahead and do this. I don't think I'm going to be able to come up with the example I was looking for, but this is the absolute value of 52, because the first thing that you have to do is subtract with inside the parentheses. Okay? It's different from saying the absolute value of 72 minus the absolute value of 20. Now with this particular example, we're going to get the same answer. Absolute value of 72 is 72. The absolute value of 20 is 20. 72 minus 20 is 52. We've got the same answer. And you can say, okay, Miss Betsy, it makes no difference. We got the same answer. Let me do a different illustration for you over here and illustrate to you what I really wanted to show you. I was trying not to work with negative numbers. These should be familiar to you because they are integers that you've been working with. But let's say that we had the absolute value of 72 minus a negative 20. What are we going to get there? Well, remember, our absolute value bars have to function as if they were parentheses. So we're going to perform this operation inside here. 72 minus a negative 20 is 72 plus 20, absolute value of 92, which gives us 92 as our answer, where we put everything inside. What happens if we took this very, very differently? And we said the absolute value of, now I'm not convinced that this number's showing up really well, this marker's showing up really well. Let me go back to red for this. I'm going to erase this problem because here we saw that it didn't matter if we put everything that we were doing inside the absolute value bars or if we split it apart. I want to split it apart over here and say, what if we have the absolute value of 72 minus the absolute value of a negative 20? Absolute value of 72, distance from 0 on the number line is 72. What's the distance from 0 on the number line of negative 20? Remember, we said it's a number, but it's a positive sign. It's 20 units. 72 minus 20 gives us 54. This is the difference that I was looking to illustrate to you. The absolute value of a difference. The absolute value of a difference right here, we're taking the difference of two numbers here first. We're subtracting two numbers, and then we're finding their absolute value. You get a different answer than if you just subtract two different absolute values. This might be a little bit unclear to you. If it is, that's all right. Just the way, the key thing that you need to remember here is treat absolute value bars as parentheses. Follow your order of operations correctly, and then you'll make sure that you get your proper answer, because this says first do your subtraction and then take the absolute value. This problem over here says first find the absolute value and then do subtraction. So this is an example pretty early on in the book of how terminology can sometimes be a little bit confusing. Don't let it be. There's nothing to worry about. This is the end of opposites and absolute value, and I'll see you next time.